The COVID-19 pandemic has focused surgeons and healthcare systems on the aerosolization hazards of minimally invasive surgery and its devices. Energy and articulating laparoscopic and robotic instruments contain hollow spaces in their shafts and handles to allow cabling transmit electrical energy to the instrument tip and tissue. While much attention has been placed on the management of smoke that occurs during cautery by instrument activation, it may be less obvious that such instruments may act as chimney flues for interperitoneal gas to flow unfiltered directly into the operating room environment. This gas will contain smoke, but also simply the carbon dioxide used to distend the abdominal cavity and any associated aerosolized cells and virions. Here we see the gas transmission via a ligature device using high-speed Sleren imaging in a high-fidelity surgical model. Carbon dioxide is directly channeled to the exterior via the instrument shaft. As a gas with different density to room air, CO2 is optically distinct by this assessment modality. The device has not been activated. The gas leaking is that used to make the peritoneum, leaking directly out into the operating room. Carbon dioxide leaks also occur with instrument insertion into trocars, but we'll focus on that mechanism of pneumoperitoneal gas escape separately. At higher insufflation pressure, more carbon dioxide leaks and the gas jet streams become more turbulent in nature. With low pressure pneumoperitoneum, the effluvium is less but still evident. Clinically, a specific thermographic camera, the FLIR GF343, confirms this mechanism of carbon dioxide escape during actual operations by its sensitive visualization of CO2 gas through its specific near-infrared spectral absorption characteristic. There are different viewing modes with this visualization system, including a high sensitivity mode that uses digital subtraction to augment moving gas flow. In addition, we see a greater tendency for the gas to move around the operating room versus the laboratory, due likely to the impact of in-theatre airflow around the operating field. This is due to the combination of positive pressure room ventilation and additional factors such as surgical movements and patient temperature. These gas streams confer the potential for pollutants and pathogens in microdroplets and vapour to contaminate the operating room team. A similar phenomenon is seen with robotic instrumentation. Here we can see 4 gas jet streams projecting vertically downwards, with another more turbulent jet directed posteriorly. Similar jet streams are seen with lower pressure pneumoperitoneum, although the gas flow is less turbulent and somewhat lower in volume and velocity. Higher pressure pneumoperitoneum is commonly used during robotic prostatectomy to reduce bleeding from veins during dissection. Again, this mechanism of gas leak is confirmed to occur clinically using the FLIR GF343. Not all energy devices, however, act the same. This harmonic instrument causes gas leaks with trocar entry like all other instruments do, but shows no sign of gas venting via the device itself. Ultrasound dissection acts differently to cautery, and its tendency to create debris and particularization intra-abdominally needs to be also considered in selection of energy devices with regard to aerosolization hazard, as unfiltered gas can still transmit directly into the operating room from the abdomen via the ports. A simple hook dissector instrument doesn't allow gas through its shaft at all. This information reinforces the rationale for personal protective equipment alongside adherence to guidance regarding smoke management in trochlear etiquette. It also suggests a benefit in risk mitigation for simpler operating methods and technologies, including hook diathermy. It should emphasise that surgeons need to understand their instruments fully and consider deeply all aspects of their construct and operation in their duty of care for patients and for the whole operating room team.